Most people assume building your own generator is either impossibly complex or too good to be real. But what actually happens when someone decides to try it anyway? At first, the idea feels simple. You're trying to solve a very real problem. Your energy bill keeps climbing month after month and nothing you do seems to slow it down. You turn off lights, unplug devices, adjust thermostats, and still, the numbers don't make sense. So naturally, the thought comes up, what if I could generate my own power? That's where the curiosity starts. And usually, it begins with research. You start looking into solar panels, wind turbines, backup generators. On the surface, they all seem like viable options, but the deeper you go, the more friction you encounter. Solar systems require a significant upfront investment, not just panels, but installation, permits, batteries. And even then, performance depends on weather, location, and maintenance. Traditional generators rely on fuel. That means ongoing costs, noise, and limited runtime. So the idea of building something yourself, something simpler, starts to feel more appealing. But this is where the experience becomes frustrating. Because when people try to figure it out on their own, they run into a wall of scattered information. Diagrams that don't match, tutorials that skip steps, technical explanations that assume a level of expertise most people don't have. You try to piece it together. You watch videos. You read forums. You compare designs. And the more you try, the more it feels like you're missing something. Not because you're incapable, but because the process itself isn't structured. It's like trying to assemble a machine without knowing which parts actually matter and which ones are just noise. So people start experimenting. They buy parts. They test configurations. They adjust components. Sometimes things move. Sometimes nothing happens. And that's where doubt creeps in. Was the concept flawed? Did you miss a step? Is this even supposed to work? From the outside, it looks like trial and error. But underneath that, there's a deeper pattern. Because most people focus on the visible parts, the wires, the magnets, the structure. They try to replicate what they see, assuming that if they copy the setup, they'll get the same result. But systems like this don't depend only on what you can see. They depend on relationships, how forces interact, how balance is created or intentionally disrupted, how motion is sustained, not just initiated. And that's where the gap usually is. Not in effort, but in understanding. It's similar to trying to build a mechanical clock by looking at the outside. You can recreate the shape, even the components, but if the internal relationships aren't aligned, it won't keep time. The same thing happens here. People replicate the structure, but miss the mechanism. And without that, the result feels inconsistent. But then something changes. At some point, instead of trying to build a generator, people start trying to understand what the system is actually doing, not just the parts, but the role each part plays. They begin to see patterns, why certain configurations create motion, why others stall, why small adjustments lead to completely different outcomes. And this is the turning point, because the real issue isn't that building a generator is too difficult. It's that most people are trying to copy a result without understanding the structure behind it. Once that shift happens, the process becomes different. Not necessarily easier, but clearer. Instead of random attempts, there's direction. Instead of guessing, there's reasoning. And that changes how people approach the entire idea of energy generation. It stops being about chasing a shortcut and starts becoming about understanding systems. What makes them stable? What makes them efficient? What makes them scalable? Because in reality, the goal isn't just to build something that works once. It's to understand why it works at all. And when you look at it from that perspective, a lot of the confusion around DIY energy starts to make sense. Why some people get results, why others don't, and why the same design can produce completely different outcomes depending on how it's applied. So if someone decides to build their own generator, what actually happens? They don't just build a device. They go through a process, from curiosity to confusion to experimentation to understanding. And that process is where the real value is. Because once you understand the structure behind a system, you're no longer dependent on guesswork. You're working with intention. And that's what separates frustration from progress. If you want a more structured breakdown of how these systems are approached, what actually matters, what to pay attention to, and how to think about the process, you can find a practical guide linked in the description. It walks through the concepts in a more grounded way. And if you're interested in exploring more topics like this, you can subscribe for future videos. That's where we'll continue breaking these ideas down, step by step, without the noise.